1240 we finish.
Yeah, it is.
Okay, I know I've busted your brains a little bit here, I'm so sorry, but it's just good to get over this and then we can do other stuff a bit later. Okay, so I'm just going to do one more of these. I'm just going to choose one actually. What shall I do? Do this one. Find the area of the region bounded by those graphs. Remember, I didn't get the answer last time because what's the mistake did I make the count? Oh, I did get the answer, I did in my head. I got the answer in my head, but not on the calculator. No, minus. So see, even my brain doesn't work when I use a calculator. That's why quite often I avoid the calculator. It's not being smart why I avoid the calculator, it's because I'm dumb. I have to avoid the calculator, I'll make silly mistakes.
You've got you in the calculator, that will just plug it into a
Graph. Yeah, I was just rushing it.
Yeah.
So find the area. You notice that because my confidence had gone down because I got the wrong answer on the first one, what then did I start doing? Start making mistakes. And see how that does that? It does it with everybody, and you start then self-doubting it. It works. You know, I've had some nightmare lessons before, especially when I was a young teacher, but that's what happens sometimes. It really does. It's okay. Let's keep plugging on. So find the area of the region bounded by the graphs of y equals the square root of x and y equals x squared. Now, you don't have to know this, but it's a lot more useful if you know that x squared looks like that. You don't get any extra marks to do this, it just looks nicer. You know what y equals the square root of x looks like? You know what I mean?
The root of x is.
Yeah, it's this one, it's a bit of a strange one, it's like that. So the reason why it's like that, because look, it's like this. It's y equals the root of x. If I square it, it's y squared equals x. It's like an x squared on its side. I was saying to a few of my other team this morning, just plug a few values in if you're not sure, you know, you'll find it. It's not cheating to plug a few values in. So ultimately, it's got a cross. Oh, by the way, this was really confusing some of my guys this morning. They will use different words. Bounding means they are going to cross each other twice. If they give you more than one thing, if they say, you know, this line, and this line, it means like you're creating a fence and you're bounding things. What other words have you noticed they use instead of bounded? I wish they wouldn't. They use what's enclosed, yeah? Area in between. I don't know why they use so many different things, but they could use all of those. Right? Just draw it and you'll find it. Now, we've got to find that area bounded by those two things. It's going to be easier to obviously do the new trick that we've learned. Remember, instead of y equals the square root of x, I prefer to do x to negative a half. This could be calculator or non-calculator. I'm going to do it as tech-free. Because you know so bad I don't have a calculator today. So you can do it on the calculator yourself. So, we've got this. We just need to find the 2 points. I actually know the first point where the cross is there. I just need to find point A. So to find point A, I'm going to do where they intersect. So I'm going to say it's where the square root of x equals x squared. And you're allowed to do that. And what you can say, oh, when's the square root of x going to equal x squared? Well, it's going to equal it quite a few places. If you're on a calculator, you can use your calculator to do it. I think most of you probably prefer to use your calculator. You get a y equals x squared and y equals either x. Whoops, okay?
Yep.
Y equals, make sure you have your things on as well, because a couple of teachers, we have to pay for it if we don't have this on the same view. If you don't have your case on, and so if your case breaks, you have to go in. There's a few people, teachers included, not got the cases on at the moment. We are really risking it in case clumsiness happens. We've got that, I'll put x to the half. If I draw it, notice that looks absolutely horrible with the drawing, so I'm going to go V window, standard. Don't freak out, we go V window, standard, and we redraw it again. Phew, it wasn't that bad. And we can plus in if you want. So if you have that, you find where it was. You can just go G-solve, intersect, and you go along to find the 2 points. If it was non-calculator, you just do this. You do it where x equals x squared, or it's where x equals x to the 4. Now a lot of people look at it and go, ooh, that's a bit weird. 0 could be on the answer. What could the other answer be where x equals x4? What other number could it be? 1. Yeah. Now instead of thinking about it, this might seem weird. We don't bother thinking about it in maths. We just do exactly what we've always been taught. I just factorise it, and I say by the null factor law, x can equal 0, or x cubed minus 1 equals 0. So x cubed equals 1 or x equals 1. See, I did it that way, but if you can spot it, but you should be careful. If you try and do spotting, a lot of you will only spot the 0, not the 1. But if you spot it, you spot it. Cool. So now I put 0 and 1. And remember, this is where I lie to you because I don't do this. It doesn't really matter which way around you do it, but it does matter to me because I like it to be positive. So the higher one is actually x to the half minus the lower one, which is x squared. Now, just be careful with that. I probably haven't been very clear with my explanation. If you look here, in fact, x squared is higher than that there, isn't it? But where do you look at it? It's higher where the bit you're interested in. So the bit we're interested in, the square root of x is a bit higher. So only look at the area you're interested in. Not a big deal if you don't know. Don't know why I put x to the 4 there. It's x to the half. You then do equals, raise the power by 1, so it's 3 over 2, divide by the new power. Raise the power by 1, divide by the new power. This is just practice, practice, practice. Divided by 3 over 2 is times it by 2 over 3. So we've got that. And then we can very carefully stick in 1 and 0. Stick 1 in and 0, so it's 2. 1 to 3 over 2 over 3, plus 1 cubed over 3, minus 0, so it's going to be 2/3 minus 1/3, which is 1/3. I actually find them quite relaxing, they're quite nice questions. You know, there's only so many ways they can ask you one of those questions. You will get one of them. You will. You know, so it's just that extra mindset. I think people forget that x to the half is the square root of x. Or they do it the wrong way around, and it's not a big deal, because instead of getting 1/3, what do you get? So if you get 2, you get negative 1/3, you then just say the area is positive, so you just say the area is 1/3. It's not a big deal. No need to redo it if you got it the wrong way around. Alright. A couple more. Just want to look at now. These, have you noticed, are the icky ones. They can be really, really nasty. So you just got to be mindful that there's only so many of these ones that you can do. So if you look, these are applications of integration. All you need to do though is just have an idea that this is just a way of finding things. And I'm going to go back to my term outline. If you look here, this is all they have for applications of integration. Calculate the area of a curve, calculate the total change, calculate the area between the curves. So some of this is actually beyond the scope of the course. So if you go back to this, quite a few of this is well beyond the scope of the course. So you're welcome to have a go at these, and I will do some of them with you, but there's nothing to freak out about. These will be all complex and unfamiliar, because they're all beyond the scope of the course. Do you see what I'm saying with those? And say, with this is, again, looking at limits. This is beyond the scope of the course.
So I'm not in out.
No.
Because I was reading it.
For both of these, just so we know, I'm actually going to put by the side of it. I'm going to put extension for both of them so you can actually see that. So this one is extension. I'm just going to keep it on so I can do it. They're both extensions. They are interesting because they're like a little bit of a workout, because they can show you what some of the really like stupidly hard ones I might look at. But remember, most of you in your SMART goals should be working on your simple familiar. Are these going to be helping you with simple familiar? No, definitely not. A definitive no. So they are extensions. When the people wrote this book, they had a little bit of a guess what that meant. But if we go back to our term outline, it tells you exactly what we need to do. And what I would like you to do over the next couple of weeks, this is a big thing to ask you, but really I think it's important. See if you can make sure you know what each of these bullet points mean. Now, for at least half of them, you're going to have to ask me. A couple of people have done it, one in this class and one in the other class, and they ask me for most of them. There's nothing wrong with asking me, because you don't want to guess and guess the wrong thing. But I just want you to realise that this is how the exam will be written, not by your book. It will go by this. So they won't use some of the horrible terminology. I love this book, but it does use very silly terminology sometimes. It will use this terminology. But you get some of this, I don't like, but tough, I've got to use it. So again, looking at this integration, those are the two extensions. Does that make sense? I'm going to do one with you though, because it's quite a nice one. Which one am I going to do? Actually, I'm not going to do it. I'm just going to talk you through it because I don't want to spend time on this because it's an extension question. If I had something that asked me to do the average of something, what do you do to find the average? And it sounds like a silly question, but think, what do you do to find the average of something? So if I said to you, like, I know it's a silly question, but what's your age?
I'm 16.
16. What's your age? 15. What's your age?
16.
What's your age? 16. So what was it? 3 16s, yeah? So what I do to find the average of your ages, I do 16 plus 16
We do this in
plus
psychology.
16, yeah?
Yeah.
Plus 15 and divide by 4. That's the average, isn't it? Yeah?
Yes.
Yeah, happy with that?
Yeah.
Now, we know that, we've known that's the average of what you mean, by the way. Yeah? And this is the same thing, you actually know it works now, so you can be smart here and tell. All in psychology, they just give you the formula. All it is, though, is you've now got a new trick to do this. So if you want to find the average, you add it all up and divide by how many there are. But if it's over an infinite amount of time, what can we use to add the area up? What do we know is the area now? We can use the what? The integral. We can use the integral. Beyond the scope of the course, definite integral. Beyond the scope of the course, but really interesting because, as Jazz is very spotty, it's actually in science sometimes as well. So that's the only reason I'm just going to introduce you to that. But it's interesting. Is there any need to do any of these? No. Okay? I've put none of these on your test. Because I've done your test. So none of this one or this one is on your test. And what I will do,
1 of 10 to you.
none of application of integration or the area under its limit is on your test. I promise you, I wrote it. I know that it's actually been recorded, so you've got witness. Okay? That's why I recorded it. It's not on there, I wrote it. I will double check to make sure it's not on the external, but that's ages away, and I'll make sure I know that before then. Okay? And I can easily show you a couple. So the only reason I showed you is just, it's interesting. Isn't it cool? It's just a different way of doing it. It's add it all up, divide by many. It's not on the course, because if you look on that, does it say that anywhere? No. So it's not on the course. It's as simple as that. They probably just put it really as a use for something else. Yeah? Again, it might make you feel even better now, so I can put it in black and white. Did I mention really anything else? I mentioned 10G a little bit, which I'll look at probably in the context of a couple of questions, but that's it. Okay? Very well done, guys. That's it, really. That's what we've got to do now.